10.5. Now, this is area and arc length. In polar. Now, this is, guys, this is how you're going to see polar coordinates on the AP exam. Is finding area and arc length. Generally, they're not going to ask you just to sketch a polar coordinate. Okay, you'll probably have to find a derivative or a slope at a point. You've got that, but then you've also got area and arc length. Now, but luckily we have some pretty simple formulas for area and arc length. So area in polar coordinates is equal to 1/2 the integral from alpha to beta of f of theta squared d theta. Where f of theta is the radius. F of theta is equal to r. Example. Let's find the area of one petal of a rose. Okay, just one petal of the rose of the curve r is equal to 3 cosine 3 theta. Now, what do you think the hardest part about this is going to be? Finding what of the one petal?
The area.
Well, this is the radius, right? This is f of theta. All we got to do is plug it in here and square it, right? Alpha and beta. That's the hard part. Where does that one petal start? Okay? When you graph this, that's why you need, most of these are going to be calculator problems. Okay? Because you're going to graph this and you've got to find out where this thing starts and where it ends. Now, you can use any one of them you want. Now, if you watch this thing graph, it starts here, and then it does this, and then does this, and does that. Now, if I want to do one petal, and also, how many degrees does it take to get to that? Do y'all remember that from pre-cal? Huh? Okay, let's get a calculator out. Grab a calculator.
Julie wants to know the question.
I got to find alpha and beta in this problem. So when we go to mode polar, go to y equals 3 cosine 3 theta. 3 cosine 3 cosine 3 theta. Now, when I grab, zoom 6.
Window problem.
Okay, that happened really fast, right?
Slow down.
Let's go to window and see what our theta min is 0, theta max is 6.28. That's 2 pi, right?
Yes.
Okay, let's switch that to just pi. Pi day. Let's graph it just to pi. You know what? It graphed completely from 0 to pi, didn't it? Okay, what about a little bit less than pi? What about pi over 2? Change window, make this second pi divided by 2.
Oh!
So it graphs halfway, right? So, pi. Okay, from 0 to pi. Now, I want to know, I need to find out from where to where, though. Now, if all the way is 180, right? How many would just one of these be?
60.
60, which is pi over 3. right? So I know that one loop of this is pi over 3. The easiest one to find is going to be this beginning one. So, but that starts at 0, right? So pi over 3. What if I went back pi over 6 and forward pi over 6? Would that make one leaf?
Yes.
One petal? Okay, so let's integrate. This is how I find alpha and theta, or alpha and beta. Is you have to look at the way it graphs, restrict the graph, and then figure out what radians you need to do. It's the fastest way to do it. So negative pi over 6 to pi over 6 of 3 cosine 3 theta squared d theta. Now, we're going to do this.
You're finding the area of one petal?
Yeah, we're finding the area of one petal.
Wait, sorry, how did you know to start at negative pi over 6?
Well, because I know the complete revolution, the complete graph can be made in pi.
Yeah,
Each petal is a pi over 3.
I got that.
Okay? But this is 0, right?
Um,
So I'm going to go back pi over 6 and forward pi over 6, which is pi over 3.
okay, I see.
Okay? I could have gone, okay, from pi over 6 to what's pi over 6 plus pi over 3? What's pi over 6 plus pi over 3?
Pi over 2.
This is 2 pi over 6. Well, it's pi over 2. Yeah, so I could have gone from pi over 6 to pi over 2. That would have given me the area of this petal. Or I could have gone from pi over 2 to whatever pi over 2, I guess pi over 2 to, what would that be?
Oh no, it's
Yeah,
5
so
pi
5
over
pi over 6. I could have gone from pi over 2 to 5 pi over 6, and that would have given me the area of this petal. Yes, sir.
What if you did something weird like 0 to pi over 3?
Yeah, it's
And it would give something that's not bounded.
yeah, it'll give you something that's not bounded. It'll give you, I'm not sure what it'll give you. We can try it in a second.
That's weird. Isn't it
Okay.
1/2 of the integral?
Do what now?
Isn't it 1/2 of the integral?
Yeah, it's supposed to be 1/2 integral. Yeah, 1/2. Sorry. I didn't put that down. What's that? They skip so much stuff and they do stuff. Power reducing formula. What is a power reducing formula?
Don't ask me.
It's a formula I like to use in my spare time.
Okay. So this one, they go ahead and square this. So this is 1/2 integral from negative pi over 6 to pi over 6 of 9 cosine squared 3 theta d theta. They pull the 9 out front, make this a 9, and now they turn this into 1 minus cosine 6 theta. Is that a double angle?
It's
Why don't you have to square the 3 theta?
Well, because we just squared the cosine.
Oh.
Yeah, we squared the cosine.
I think it is.
So, what is that? What is that formula? What's a double angle?
This. The double angle cosine.
Double angle cosine
1 minus cosine.
for cosine squared?
Are they half angle in here? That is the power reducing formula. Let's do it.
Add 1 divided by 2. It says it's 1 plus 2 cosine, or 1 plus cosine 2u over 2. Okay, they put it, yeah. That's what they're doing. Yeah, they use the double angle formula here for cosine. So this is 9/2 integral negative pi over 6, pi over 6, and this is 1 plus cosine of 6 theta over 2 d theta. I've lost my place now. Alright, I guess move this 2 over, make that a 4. What?
No, you wouldn't be able to multiply both by 2, would you?
Why?
Because there was a half on the bottom, so if you multiplied the whole thing by 2, then it would be 9, the integral, and then 1 plus cosine 6 theta.
Huh?
Wait, where's the
No, because there's no equals. What?
It's over 2, so you can multiply by 1.
Yeah, if this was over 2 and I moved it 1/2 over here. Sorry. Now I can. This is just what?
So it's 1 over cosine 6 theta over 2. And then
Yeah, it was over. Yeah, it's 1 plus cosine 6 theta over 2.
Okay, where'd you get the 6 theta?
It's a double angle formula
Okay.
because you have to double 3 theta.
Okay.
Okay, so far? And come on,
D theta on the end, right?
d
So
theta.
it's an A theta. That's like negative? Negative?
No.
To be honest, you students for AP students, you have it perfect. It's 7. We're all OCD.
No, you're always CDO.
Hey, it's COD.
Oh, no, that's OCD with the letters in the correct order.
Please calm down.
It is.
It's not about order, it's
Okay, so this is 9/4 times the integral from negative pi over 6 to pi over 6 of 1 plus 9/4 the integral negative pi over 6 pi over 6 of cosine 6 theta. Now I can do a u substitution on that one. This becomes just theta. I'll do that in a minute. This one is u equals 6 theta, du is equal to 6 d theta. So I need a 6th and a 1/6. What? So that reduces by 2 and 3, so we get 3/8 integral
slow down. I'm sorry.
sine u du. And my limits of integration for this one become negative pi to pi.
Oh, okay.
Okay?
Not yet.
Okay. I'm just rewriting this one.
Okay.
is that negative pi on the
Where?
Yes.
3/8?
Yes, that's negative. Man. They do this whole problem in like 4 steps.
Yeah, no thanks.
Yeah, I know. Okay, so we ready to take some integrals? What's the integral of 1? Theta. Oh my god. 9/4 theta, that's negative pi over 6 to pi over 6. So that's 9/4 times pi over 6 plus pi over 6. Minus negative pi over 6. What? Which is 2 pi over 6 pi over 3 times 9/4, which is 3 pi over 4.
Minus.
Plus. What's that?
No, I'm just looking
Okay. Now we're going to do this integral. So this is 3/8. What's the integral of cosine? Sine of u evaluated negative pi to pi. What's sine of pi? Zero. So it's 3/8 times 0 minus and sine of negative pi?
it.
0. So what's the answer?
0.
The answer is 3 pi over 4.
Yay!
So 3 pi over 4.
I thought we were asking what sure.
The answer to that one
Yeah.
was, yeah.
Thanks, guys.
Alright. Now the question is, did I do it right?
Nope.
Yay! I got it right. Alright.
Would you start the whole thing over?
What?
Would you start the whole thing over again? When we take this
I would have had to figure out what I did wrong. Yeah. I wouldn't have said, oh, but y'all can do it right. I'm not that kind of person. Okay. Now,
You guys can figure it out, you know?
yeah.
Not like you're so strong. You guys say page. You know, or say it again. You say it from the page. Okay, my legs. That's so. What were you gonna say? I need to run more because I. No, you won't. It's okay. I can push myself, so I'm fine. Okay. I've been trying to do better. Same.
Okay. New problem.
No.
So we have r equals 1 minus 2 sine theta. It says find the area lying in the region between the inner loop and outer loops of the lamacon.
Lamacon?
Lamacon.
What is that?
You'll see.
It's the thing with the little. It looks
It's
like
the
a
thing
bug.
with the thing, you know.
Yeah, totally.
The circle with the
Yeah.
A little dimple. Oh, the bud.
The butt, yes, it's the butt. With the hole.
You had
Whoops.
to change your.
Whoa, sir.
No, Tyler, you did the curls. I didn't know that.
Okay. Do what?
I'm done. I'm out. I'm checking out.
Now, it says find the area between the outer and the inner. So, the graph, what we're really trying to find here is you have this lamacon, whatever. I want to find all of this area, not the center. Now, what's the hardest part about this?
Crying.
No.
Alpha and beta.
Trying to find alpha and beta. Do what? Yeah, finding those points. I mean, and this, guys, this can be tough.
So, what do you want to do? The way it does it first, it draws a little tiny circle inside and then draws the big circle outside.
Yeah.
So we would want to take, integrate from the time that it makes a little tiny circle and then
Until it stops, until it finishes. Right. So,
subtract the two areas.
yes. Yeah, that's exactly what we're going to want. What we'll want to do.
Yeah, there you go.
So, if I go back to y equals or change my window, let's see. How far do you think, how many radians do you think it's going to make? Pi over 2 to make that little circle?
No, I think
It's just pi.
For the whole thing or for
that's not
No, for the
enough.
whole circle.
Okay, now see, it didn't start there. It started right here. What we need to do is find out, it needs to start right here at 0, 0 to make this little loop. Right? Pi over something.
What just put in?
I just put in pi over 2.
It's probably pi over 4.
Okay?
Just started. Just put the minimum.
Oh, minimum pi over 4?
Yeah.
Quit.
You broke it.
It's on. Okay.
And then 3 pi over.
No, it's a little much.
Oh.
Pi over 3? Or pi, I'm sorry. That's pi over 4. Pi over 6. Pi over 6, so we're going to start at,
Yeah, E is good.
crap.
It's not like even.
Second pi divided by 6. Okay, so it starts there. Now, how far does it take? Now, that was pi over 2. So it's going to go a little bit more than that. Like 5 pi over 6? 5 pi divided by 6.
Wait, started where?
There you go. So pi over 6 to 5 pi over 6. What?
Did you guess or 3,000 foot?
No, it was a little bit more than pi over 2. And I figured since it started at pi over 6, it might be a multiple of pi over 6.
Yeah.
And I didn't think it was going to be pi over 3. So I was just guessing. So I'm telling
Is that
you.
what this is? It's gonna be guessing today.
Well, I'm sure there's ways to do it.
But you don't.
But, I mean, if you are really, really good at polar graphs, and you just, oh yeah, that's always starts at pi over 6. I don't.
Do you
It's
look
been so
black
long.
guy?
What?
Do you look black guy?
Yeah.
Who beat
You
you
ought to
up?
see the other guy. He didn't have a mark on him.
Mm-hmm.
No, my wife hit me. It's spousal abuse.
Mm-hmm.
I thought she said stand up.
Did you run into
She
something?
really said shut up. And
You ran into something.
no, I hit myself.
Whoa, I need the story. With what?
I hit
Story time.
We said don't get hurt. We specifically
I know, and it happened. It's because you said don't get hurt.
Well, I actually think he said don't die, and he didn't die.
Whoa, how did it happen?
Almost died. I almost lost an eye.
Hold on, how'd you get yourself? I feel like almost. How did it happen?
Okay, so
Which end of the hill?
the farm. Yeah. So I'm on a ladder. This is Monday.
Why did you stay up?
I know because bad crap happens on a ladder. So and I'm building a barn. Okay. But I'm on a ladder. It's Monday. It's raining and windy.
Maybe you shouldn't be building a ladder when it's raining. You should wait.
Well, I was really upset that I wanted to get. It wasn't raining bad. It was just kind of a mist. But I knew I was about to lose 4 days of work on my new barn, right? So anyway, I was on a ladder. I was holding up a 2x12, which is a really heavy board, and I can't hammer with my left hand. Okay, my left hand only will hold a biscuit. I can push food onto a fork with my left hand. I can't do anything else. So I'm on this ladder, like 10 foot up in the air, and I'm holding this board up, and I'm hammering a nail, right? Well, about that time, about a 50-mile-an-hour wind gust comes and hits me and shifts my ladder. My ladder like slides. I got my ladder on a pole, and then it does this. And right about the time I hit the nail, and when it slides, the hammer came back and hit me in the eye. And it sliced my lower eyelid right below my eyeball.
You made
No.
me not want to be a nurse.
No, I didn't go to the doctor.
Why did you do it?
Why? I got it to quit bleeding. Anyway, so I thought, oh God, I just took out my eye. That's my first thought of, So I threw my hammer down, went in the house, got blood gushing down, got the bleeding to stop finally, and looked at it real close, and it was just right there, that little spot where that hammer came in and hit it.
So you got
And,
lucky.
oh, I got so lucky. Yeah, because I could be here with an eye patch today and no eyeball.
Not gonna lie.
I
that's
know.
really
Not
cool.
gonna be lucky. Not gonna
I
lie.
know.
Should have pirated anything.
I know. And hey, you should have seen me yesterday.
Don't get on a TV.
Yesterday, no, I was even higher than that yesterday. I was up 18 feet in the air on this barn. It's I'm
Mr.
getting,
Shoots, you
Hey,
learn
look.
from your mistakes.
what?
No.
Yes, I do. I don't put nails in my mouth anymore.
Oh, that should have just been a given.
Yeah, imagine if you had nails in your mouth when that happened. That would have been terrible.
Shoots, I don't want you to lose your
There's
eye.
It was pretty. Actually, that was the first day.
If you had to wear an eye
The
patch,
second, third day, it got really bad.
Low key, if you had to wear an eye patch, I'd be jealous.
that'd be really cool.
Yeah,
Yeah, I'm
I
not
had to
saying I
put a
wanted
big
to lose
band-aid
eye.
over my eye once because one of my contacts fell out and it was giving
So
me
here's
a
my barn so far.
One time Jordan sprayed Febreze in my eyes and I thought it was going to be orange for the rest of my life.
Nice.
What are older sisters for?
What?
I see your eye.
I've never tried to blind my
I see
younger
your
sister.
It was supposedly an accident, but I know.
Yeah, it was interesting. It wasn't that painful. It didn't hurt that bad. It's just I got really scared that I hurt myself.
Same. Oh my goodness. Same.
What?
When I hurt myself, I just cry because I'm scared.
I don't want a permanent disability.
Yeah, same.
Yeah.
Maybe you should have stayed on to the locker when it's maybe.
You know, you gotta do what you gotta do.
You don't gotta.
Well, when you're poor, you gotta do what you gotta do. Yes, I could hire somebody to build my barn.
Or you could just wait till the weather's nice. Like
But,
child
see,
labor.
I'm building a 36.
Now you have 2 kids.
Yeah, you have 2 kids.
How many of your kids stand out there to make sure?
They're helping me, yeah.
Then why did
But
you
it was
pick
raining. So
So maybe
I'm
no.
building a 36 foot by 36 foot barn, and I'm doing it for under $10,000. If I had somebody built it, it would be at least $30,000.
Don't you have friends?
Huh?
Who would help you?
No, I don't have any friends. No, I don't have any friends.
Who would help you?
No, I don't have any friends. So
What about you?
now,
You gotta pay my medical.
so we know we're going to start here at 5 pi over 6. Now, if we just integrate from 5 pi over 6 to whatever it takes, let's say we go, oh, that's not what I wanted. I want here. Let's start at 5 pi over 6. And what do we want to end on? Maybe pi?
I think it
Let's
could
see
be
what happens.
2 pi. If 5 pi over 6 only got us the little loop.
Ooh. Yeah, that only went from here
it's
to
a
there.
big circle.
4 pi?
No, I think it's 2 pi.
I think it's 2
2
pi.
pi?
Yeah. I think.
I've been wrong before.
Yeah.
Oh, see,
Oh,
it didn't make it
no.
all the way.
Okay,
It went. It made it to that beginning.
Wasn't that 0 though?
Oh, I did.
Yeah, but we're just going from here.
Pi over 2 pi.
What's pi over 2 plus pi plus pi? I mean, 2 pi plus pi over 6.
7 pi over. Oh wait, sorry.
7 pi over no.
15 pi over 6.
12 no 13 pi over 6.
13, yeah.
Window 13 pi over 6. Okay, so there we go. We're going from what was it? 5 pi over 6 to 13 pi over 6. All right. Now, will that give us all of the area between that that's enclosed? And then we have to subtract the circle off? Is that right?
Yeah.
Okay. So I need the integral from 5 pi over 6 to 13 pi over 6 of 1/2 times 1 minus 2 sine theta squared d theta minus the integral of 1/2 that was pi over 6 to 5 pi over 6 of 1 minus 2 sine squared or theta squared d theta. Okay, so golly, we got to square all that out, don't we? I don't think I have enough board space to do all this problem. Because then we have to use the reduction formulas and...
What a bummer.
Okay, but y'all know how to do that, right? Y'all know how to finish this? Why?
Do it. This is the first time I'm seeing this.
You've done this integral before.
Nope.
No.
Square the first, double the product, square the last, d theta. Same thing here. So that's 1 minus 4 sine theta plus 4 sine squared theta, d theta. Now that sine squared, we're going to have to use a reduction formula. Sine squared is equal to cosine 2 theta minus 1, I'm sorry,
What?
it's 1 minus cosine 2 theta over 2. You said, huh? Because cosine of 2u okay, here it has it right here. It has it right here. Who's it, huh? Right here. Sine squared. Sine squared is 1 minus cosine 2 theta over 2. Okay? So,
Is that
It's your half angle formula.
Oh, okay.
It's your, or double angle. It's your double angle formula. It's just a different form of the double. Sorry, it's a different form of the double. Yeah, you've needed those. We've needed those all the way through this course. Said several different times. Okay, so oh my lord, I don't have enough room on this board. So this is 1/2 the integral 5 pi over 6 to 13 pi over 6 of 1 minus 4 sine theta plus, this is going to be 4 times, this is 1 minus cosine 2 theta over 2 d theta. What? Well, we'll do all that in a minute because I don't have room to do all that right now. So now this 2 and that 4 cancels to give me a 2. I can distribute the 2 through here. That's plus 2 minus 2 cosine 2 theta, which is 3 minus 4 sine theta minus 2 cosine 2 theta. Now, I have to do a u substitution on this one, correct? So if I let u, now everybody needs to look up here, because we got to figure out a way we can do this without having to rewrite this integral every time and break up every single piece. Because I know the integral of this one's going to be 3 theta. I'm sorry, it's just going to be 3 theta, right? Does everybody agree?
Yes.
Minus 4 times, the integral of sine is negative cosine. So that's plus cosine theta. Now this one I have to do a u substitution. So if I let u equals 2 theta, du is equal to 2 d theta, right? And what does that mean here?
1/2.
That means I have to put a half in front. So this is just minus, the 1/2 and the 2 cancel each other off. And then I can have the integral of cosine is sine. And now I can put the 2 theta back in. Do y'all see how I did that?
Yes.
Okay. And that's evaluated from 5 pi over 6 to 13 pi over 6. Oh, and there's a 1/2 in there somewhere.
Would you have to change it since you did the u substitution?
No, because I went back to theta.
Oh,
Okay, I put the 2 theta back in. So that was from 5 pi over 6 to 13 pi over 6. Okay, minus. Now, don't we have the exact same integral over here?
yes.
Okay, so we have the exact same thing here. This is 1/2 times 3 theta plus 4 cosine theta minus sine 2 theta evaluated from where to where?
Pi over 6 to 5 pi over 6.
Pi over 6 to 5 pi over 6? Okay. Oh, this ought to be horrible. What was that, 13 pi over 6? Oh my God. Can y'all finish this from here? Because I really got to do arc length before time.
I know where this is going.
Y'all know how,
Yeah.
okay. Okay. Phew. Yep. They do one of them and then say, in a similar way, you can do the other one and then subtract them. Because they don't have enough room in the book either. All right. Yes. All right. Arc length. Arc length. Arc length. I didn't think I said it correctly. Okay, so arc length S is the integral from alpha to beta, again, of the square root of f of theta squared plus f prime of theta squared d theta.
It's S equals, I think.
S equals, sorry. Arc length, S equals. Now you got to really pay attention to arc length.
because every other arc length we've had has been like f prime squared plus g prime squared, right? This one's not. This is f of theta squared minus or plus f prime of theta squared. This one's different than all the other arc length formulas that we've had. Every single one of them
That's
are
good.
okay. Yeah, that's just one more formula you got to memorize. Okay. All right. So let's look at an example. Let's say we have f of theta is equal to 2 minus 2 cosine theta. And find the length of the arc from 0 to 2 pi. See, they gave us which ones to find here. This one, I like this a whole lot better. From 0 to 2 pi. Now, what am I going to need from this? This is the integral of, I wrote it down up here, from 0 to 2 pi, there's no 1/2, I have a square root of f of theta squared. So this is just 2 minus 2 cosine theta squared plus f prime. What's the derivative of this? The derivative. The derivative of 2 is nothing, right?
So it's plus.
It's negative sine.
Yeah, but
So that's plus 2 sine theta squared d theta. Woo-wee. Now, we're going to be able to do this. Do what? Yeah, maybe.
Ring, ring.
Pick it up, hang it up. Hello? Yes.
It's okay, keep it
Yes.
at half.
1 second. Mr. Davis. Okay. Huh? No, she just answered the phone. Yeah, she just needs to talk to you for a second. Okay, so this is going to be square root of square. Now, can I factor a 2 out and square that? Make that a 4? Square that 2, make it a 4, and then take a 4 out and make it a 2?
You have to, it's a binomial.
I know, but I can still factor a 2 out.
Look at
And make that 1 minus cosine theta. All squared. Squared that makes it a 4. Right? Squared this makes that a 4. Right? Factor a 4 out of that and make that a 2 out here. So the 4's are gone. Makes it easier to me. So this is square the first, double the product, square the last, plus sine squared. That's 1. That makes it nice. 2, integral 0 to 2 pi, square root of 2 minus 2 cosine theta, d theta.
Wait. Oh, yes. Okay, figured it out.
Now what could we do with that?
Um,
No. I mean, I can take out a square root of 2, make this 2 square roots of 2, and this is the square root of 1 minus cosine.
sure there's no.
Yeah, but that's just 1 minus cosine. It's not 1 minus cosine squared. Oh, it's a half angle. That's what the book is using. Where's the half angle formulas? Huh? They don't even have them in here. Yeah, half angle. taking the double angle and reworking it. So what if we took sine squared u equals 1 minus, hang on, let's do it this way. Was that 1 minus cosine?
Yeah.
No, I gotta do it that way. Okay. Cosine of 2u is equal to 1 minus 2 sine squared. U. Right?
Okay.
Okay. Now, if I subtract a 1, u, right? Divide by negative 2. Go ahead and turn that around. Sine squared u. Okay? Is everybody okay with that?
Yes.
Now, what if I do a variable swap and make this u over 2 and that just u? Yes.
Wait, can you explain that again?
If I make this u over 2 and that, or if we do like n, if I make u, or what variable do you want? X? U equals x over 2. That gives me 1 minus cosine x, because it's x over 2 times 2 over 2 equals sine squared x over 2.
Okay.
Mm-hmm. How's it help us? You'll see just a second. Now, if I multiply both sides by 2, this is 1 minus cosine of x is equal to 2 sine squared x over 2.
So we put that in.
That inside the square root. That's the square root of 2 sine squared x over 2. But I did a variable swap. So du, that was theta. So d theta is equal to 1/2 dx. So I gotta have a 1/2. What? What? 2. I gotta have a 2. D theta. I know I'm in a hurry. And a 1/2 out here.
In the radical, you get another 2, so the 1/2 and 2 cancel out, and the radicals combine to make it 2 outside the integral, right?
Did you, for the, so now for the e, you put
Yeah.
X over 2, but did you do to the cosine side?
Yeah.
It wouldn't be like X over.
Yeah, I'll put x over 2 times 2 is just x.
Oh, so I just did it too, okay.
Yeah.
Is it from 0 to pi now? Because
Yeah, and that would be from, these are thetas. Now it'd be from 0 to 4 pi.
I tried.
And this is just square root of 2, right? Oh, crap. Okay, so we end up with square root of 2 integral 0 to 4 pi. This is the square root of 2 times sine of x over 2 dx. And that turns that into just 2, which is what you were talking about, right?
Yeah.
Sine x over 2 dx. Now we can do a u substitution back. U equals x over 2. Du is equal to 1/2 dx. What? So I'll need another 1/2 and a 2 over here, so that's 4 integral 0 to 4 pi sine of u du. God. And, hey, the integral of sine would be negative cosine, so that's negative 4 cosine of u. Oh, did I just, I mean, I gotta switch that 0 to 4 pi, don't I?
Yeah, it's
What's it now?
2 pi again.
0, 2 pi.
Yeah.
Wow.
That works out. I'm really confused about what you just did.
Yeah, so am I. Negative 4 cosine of 2 pi is 1 minus cosine of 0, same thing. What? Yeah, it has to be wrong. I know I made a mistake.
It's probably
We'll do
I'm
our
just,
link
there's a negative in
tomorrow.
there somewhere that I just messed up on.
Yeah, so
Okay,
art looks.
so what are our homework problems for area?
Okay, let me get them to you.
So can I just put an X over that? Is it all wrong?
No, we gotta fix it. Hey, that's part of your assignment to figure out what I did wrong.
I don't even know what you did right.
Alright.
So Jake Davis, that's your homework assignment.
You don't actually do the rest of it.
We'll do the homework for you and you can figure out what he did wrong.
Yeah, I think
Okay.
he's good.
Yeah, I think we're all good.
I got lost.
Yeah. Words came out of his mouth and I knew they were coming. I just didn't know what they were actually.
Congrats, why don't you just start runs for
Step back.
Yeah.
Like on the wrong side. And then
That's
like,
right.
nobody was there.
But I guess it's not your first.
Well, I mean,
You sort of start at the end of
I
the
did
last one.
placements at the very end of the last one of the season, so
Mark it.
I didn't really have an opportunity to
Done that before.
Exactly.
Alright, let me see.
Ah, no, take
See how much of this I got covered today.
You know how that turned out.
Started so much more.
I need to work on PE support and probably because I've never taken it like that. Like I just accepted the comp, so I need to practice it.
Yeah, if you don't like support, you can.
I love support. It's just hard because I know
Actually,
I can't carry it.
there are people that make support that's quite moderate. Like you can carry it. You just have to be really good at getting
Okay. Yeah, that was like.
Everybody's like,
Seventh period.
Alright, 6 through 24,
okay,
multiples of 3.
thanks.
Okay, there's some odd ones in there.
Well, yes.
When a multiple of 3. Yeah, if there were an odd ones, I wouldn't even try.
Yeah.
That's a cute thing to admit to your teacher.
Wait, what?
That's a cute thing to admit to your teacher.
I don't think
One more time,
shoots can
Gabby.
judge
That's
us.
a cute thing to admit to your teacher.
I feel like shoots can't judge us too hard. He stood on a 10-foot ladder.
Sometimes I
Hey,
can't figure out
just
the
because I make
And
lapses in
gave himself
judgment.
a black eye.
But did I die?
Not yet.
Almost did. You could.
No.
Another
Hey,
look.
you could die any day, anytime. I could die on the way home today.
You know what increases your chances?
What?
Standing
Stand
on
on
a chair.
ladders in the rain?
Have you been?
Oh, that's ladder.
Nick's dying to learn this.
Okay, this is really hard for me to hit, but you know in cartoon world where the person or the Bugs Bunny is standing in one end of the limb and he saws the
squish that.
No, it
Did I tell you what the